Hey guys, welcome back to Sushmiaura Classes. We try to help you with 1% daily improvement. So let's get started with the question from interviewer. So today's question is explain the bias variance trade-off in context of machine learning models. So if the interviewer asks such question, the best way to answer is that first you start with the introduction. Then you go for explanation of what is bias. Then you explain what is variance. Finally, you conclude by explaining the trade-off. So let's get started. How you should start. So in machine learning model, the bias variance trade-off refers to the balance between the two sources of error that affects the model's performance. Next step one, what is bias? So bias refers to the error introduced by approximating the real world problem with simplified model. Okay. High bias means that the model makes strong assumption about the data, which may include the uh, which may miss the data, important data. Okay. So underfitted model cannot capture the underlying patterns in the data and can perform poorly on the training data set. You may or may not explain it, okay? Uh, or if you explain, you should even explain what is an overfitted data. Okay? And so after explaining the bias, you should go to variance. Variance you should explain. Variance refers to the error introduced by the model's sensitivity to small fluctuations or noise in the training data. High, similarly, you can also explain what is high variance. So high variance means that a model is too complex and it includes the noise or the random fluctuations leading to overfitting. So an overfitted model will perform extremely well on the training data, but it will start failing with the test data. Now, what is the actual thing, the trade-off? So trade-off can be explained as a key idea, okay, uh, to come to a sweet spot between the um, complexity of the bias and the variance. So trade-off can be explained as, again, let me repeat. The key idea is that as the model complexity increases, the bias decreases and the variance increases. So if you come to the last slide, the balancing factor or the sweet spot where both the bias and the variances are balanced to achieve the lowest possible error. That is the point we choose, and that is where the model generalizes well to new unseen on the test data without the scenario of underfitting or overfitting. You will include the graph if the interviewer has a allows you to do that, or if you are sharing your screen in addition to these factors. So that's it for today. Stay connected, hit like and subscribe to keep us motivated so that we can come back with better contents. Thank you.